Okay, we are going to be continuing to look at paper chromatography. So I'm just going to play this video just to remind everybody what paper chromatography is. So imagine that food dye, if we put it on a piece of paper, a special piece of paper, this is what happens. Takes a longer time for it to do, but the black dye will separate into different colors as it travels up the strip of paper that's been specially treated and put in water. All right. So we're going to look at 3 new models and how to evaluate them, which means to judge how useful or accurate each model is. So each model is a diagram showing a different idea about how chromatography works, along with a written explanation. So here are the models, and I'm just going to quickly read through them so that could be helpful for you when you do the assignment. If you are having trouble with reading the assignment, you could just look at this video and I'll be reading it to you. So the color changing model is one model. The water molecules were attracted to the paper molecules, so the water molecules climbed up the paper. As they passed through the food coloring mixture, the water molecules bumped into the dye molecules, and the water molecules changed to the same colors as the dye molecules. The colored water molecules kept traveling up the paper. The blue water molecules are the lightest, so they went the farthest. The red water molecules are the heaviest, so they did not go as far. Okay, and then we have a picture showing this model on the right. The second model we're going to consider is called the growing model. So the growing model is the water molecules were attracted to the paper molecules, so the water molecules climbed up the paper. As the water molecules passed through the food coloring, they attached to the dye molecules and made the dye molecules grow, so the dye traveled up the paper. The molecules of the blue dye grew the most, so they went the highest. The molecules of red dye grew less, so they did not go as high. And we have a picture here as well showing that. And finally, the attraction model is another model we could consider, think about, make a judgment about. The water molecules were attracted to the paper molecules, so the water molecules climbed up the paper. The dye molecules were also attracted to the water molecules. Since they were attracted to the water molecules, the dye molecules got carried up the paper. At some point, the dye molecules were more attracted to the paper molecules than to the water molecules, so they stopped moving up. Okay, so those were just some brief explanations of 3 different models, and we're going to talk about what we already know about molecules, and then we'll evaluate the first model together. So in the color-changing molecules, we just read that before, so I'm not going to read that again. You could rewind the video if you want. All right. So here are some questions I'm going to ask you guys, and you could pause and discuss it with whoever you're watching the video with, or just think about the question on your own. First question, does the model explain how the water traveled up the paper? Think about that. Okay, second question is, does the model explain how the colors moved up the paper? Does the model explain why some colors went higher? And finally, does the model fit with everything we know about molecules? If not, does it conflict with statement A, statement B, or both? All right, so I'm going to explain what I mean by statement A, and I'm just going to show you actually statement A and statement B. I'm going to show you what you're going to be doing. So I'm going to go here. So on your assignment, you're going to have a Google Docs, which you're going to click on, and you're going to see a page that looks like this. And if we keep scrolling down, it goes to a page that looks like this. So those questions that I was just asking are right here on this page. So you're going to type your name. Obviously, yours will be different than Mr. Pearl. And then you're going to look at statement A. First of all, you can read the directions. It says, evaluate the 3 models described in the YouTube video. That's the video you're watching now. In the table for each model, put an X in yes or no to indicate if the model explains or does not explain what you observed in chromatography and what you know about molecules. So there's 2 statements that we were talking about, what we know about molecules. Statement A, all molecules of one substance are exactly the same and they are different from molecules of any other substance. Statement B, the properties of the molecules of a substance do not change. Okay? So those might be things that these models don't do a great job explaining. Maybe they do, maybe they don't. So first of all, if I look at the color changing model, and here's another resource I'm just going to show you. Actually, that's also here. If ever you want to look at those models again, you're going to have this PowerPoint, Google Slides available to you showing the 3 different models, the color changing model, the growing model, and the attraction model. All right, you could just refer to that. Oops. Okay, let me go back. So you're just going to complete the chart for each of those models. Does the model explain how the water traveled up the paper? If I think it's yes, I'm going to put an X here. If I think the answer is no, I'm going to put an X here. All right? So I color-coded it green for yes, red for no. And you're going to do that for each of these statements and for 3 models. So here you're going to answer the question for the color-changing model. Here you're going to answer for the growing model. And here you're going to check off yes or no for the attraction model. All right, so let me just go back here. So you're going to evaluate each model. And actually for this lesson, that's all I want you to do this time. So you're going to complete those charts on the Google Docs. All right, if you have any questions, please let me know. I know this is probably a little complicated, so I would be happy to help anybody who needs help. I'll include my email address on the assignment, so you could email me with any questions or leave any comments. Please do. I'm happy to help in any way you need. Thank you, guys.